We also have Mr. Drew Larrabee with us today. Drew is the Industrial Technologies instructor at Wrangle Public Schools in Wrangle, Alaska. Drew started his teaching career as a geologist, teaching math and sciences, but has since spent the last 4 years teaching digital fabrication, where he and his class produce some wonderful projects. Drew will be discussing the introduction of RhinoCAM to his public school students. Hi, Drew. So tell us how your students there at Wrangle Public Schools have embraced RhinoCAM in digital fabrication as well.
Well, Don, that's actually a long and twisted road to get to that point, but let me start a little bit backwards, because this is probably how most teachers are going to come into using your product. Well, maybe not quite as convoluted as mine, but as you stated earlier, I'm actually a geology major. Mm-hmm. I'm sitting here listening to Bill's explanation, and it sounded like a really neat project. But I actually started out as a vertebrate paleontologist building dinosaurs in South Dakota long ago, and then worked as a environmental engineer, and then a bunch of other stuff, and finally ended up in Alaska to teach. And came here as a science and math teacher, as you stated, and did that for several years, and that was in the far north Alaska, very, very cold area, near the Arctic Circle, where it gets dark for the majority of the year. And but I transitioned down to another school district, and they said, well, we noticed on your resume that you used to do construction and engineering and stuff. Would you be willing to teach a furniture class, a carpentry class? And I said, well, I suppose I could do that. And that class turned into 2, and then 3, and then half my schedule was done doing vocational classes. Mm-hmm. And I started
How did you like working with the students?
Oh, I love vocational. It's neat because the students come into the classroom and they really genuinely want to be there most of the time. You don't get the arguments like you do in math class. Oh my God, why didn't you do your homework?
Yeah.
So it was really fun, and I've always done construction. That's how I got myself through college, and so I love building things with my hands, and so it was really just a natural fit for me. And I found that putting science and math into the vocational classroom was a natural fit. Teaching math using vocation is much easier than teaching math out of a textbook. So I started incorporating science and math into all my vocational classes and made them a mix of STEM classes. And STEM is a term that we use a lot in education now, which is science, technology, and math. And so I started incorporating that. And I worked for that district for 5 years. Teaching that combination of stuff, and got to meet a lot of people in the state education associations and stuff, and going to different conferences, and met a fellow named Randy Huey out of Sitka, and he offered a Rhino Cam training, and this happened right about the same time I changed jobs, and I moved down to Southeast Alaska and was offered a full-time vocational position, teaching everything from welding to carpentry to furniture building and everything. And as we spoke earlier with Bill before the conference, I also learned furniture building just as a hands-on, just out of necessity, and have really developed it over the years. But I started to see that the students really have this, it's really hard to tear the cell phone out of their hand long enough to run the table saw.
Yeah.
So I decided that really needed to be incorporated into my classroom, the technology and learning to use that, because that's really the direction that our society is going with manufacturing and everything. Mm-hmm. And I was leaving an entire group of students from our school population out of my classes, because typically you get the shop kids, the kids that don't necessarily do so well in their other classes and everything.
Right.
But there's a group of kids that love running computers and are very intellectual and not necessarily willing to run the table saw. So put them into the classroom running computers. Well, Randy Huey at that time offered the training for Rhino CAD 1, and so I went and took that training, thinking, well, this is great. Let's get going. And at that time, I had one PC computer and a 3D printer, a small 6x6x6 3D printer that was given to us for the training. And I brought that home and I showed the students, and we were learning and having fun with the little 3D printer, and I realized that just wasn't going to be enough because they were eating that up really fast. And so I sat down that spring, and I wrote a huge grant to the state, enough to buy new computers for the shop, a 2-axis 50-watt CO2 laser, an additional 3D printer, a much larger one, and a 3-axis CNC router. Well, didn't know what I was getting myself into with that whole deal. And once it was all on the ground, I looked at it and said, now what do I do? And so my limited experience with Rhino, I started tinkering and playing and designing projects and calling people and making it up as I went along. And I quickly realized that the students were going to outpace me. And so I really sat down and started learning a lot. But as you guys know, schools often have a very, very limited budget. And so I decided we had to get some kind of CAM program to run our 3-axis router. And at the time, we just couldn't get the free programs to run the toolpaths and stuff that we wanted to design, and I was just learning about toolpaths and trying to figure out how to run them. And so we ended up with, and I'm sorry, I'm going to throw out a competitor, we ended up with BobCam, which was a cheap program, inexpensive, not free, and we tried to use that. And so we started out with basic 2D toolpaths and cutting some signs and some stuff like that, and just shapes and stuff. And I had a senior who did his senior project that first year and cut a great big bench. And it was it looked like a tree, and it was 3-dimensional, and it had a big round bench that went around it, and it was 8-foot diameter and 8 foot tall, and it turned out pretty well. But in the process of doing that, we learned the limitations of going from Rhino to this BobCam. We had so many problems with snap points and modifying the design once it got in there, and laying it out and making tool paths, and we absolutely positively couldn't do any kind of 3D work. We just couldn't get it to work between Rhino and then over to BobCam, and so we got terribly frustrated with it. I mean, repeatedly, just problem after problem, and it was a really difficult thing to keep the kids interested when we were having so many problems.
Yeah.
And so that's when I started looking and trying to figure out what I was going to do. And so I started talking to Rhino Cam and realized that I could afford their entry-level setup, and we got it in, and we started using that. And talk about a world of difference. It just worked well with Rhino. I mean, everything moved right over. It was a drip, just plopped it right in, and the kids could produce stuff, and no problems with snaps and planes meeting and stuff like that. And it was so much more pleasant, and the tutorial videos were easy to follow, and the kids, because they were used to working in Rhino, they could start picking it up.
Yeah, I think this would be a good point, Drew, to show the next slide here. That's
yep, and that's what I was
Rhino Cam
going to do, is go to the next slide. So yeah, if you guys could go to the next slide, that'll be perfect. So we were able to start building, and these are students, so we don't have a big budget for outside projects and stuff. But they really got a lot of interest from the community. And one of the small first projects we did was we had an individual. We've got a big shipbuilding yard here in the community that actually supports a lot of jobs. And one of the big fiberglassers came in one day, and he says, I hear you guys have a 3D printer. And I said, yeah, absolutely. He says, I've got this part in this old 80s vintage fiberglass cutter, and I can't replace this part. They don't make it, and he said to buy a new tool is thousands of dollars. He says, I just can't afford that right now. He says, can you make this part? And I said, well, I don't think the 3D printer will hold up for the part. But I said, we can make the prototype, and then we can send it to an outside service to have it minted in something else, like stainless steel or whatever. And we did. We made the gear. I had one of my students actually design this. It was an offset 45-degree face gear, and it was pretty unique shape, and I had to teach him a lot of stuff. But he printed it. We sent it out, had it minted, and the man put it right into his machine, and it functioned immediately.
Wow, that's great.
that got the community hearing about the things that we could do. So then we started getting requests for things like parking signs, and this sign that you see here on the screen is a sign for, we've got a lot of tourism in our area because it's Southeast Alaska, very beautiful. And we have tourists that get lost around our community all the time. And so the city started asking us to make signs, and these are out of the 3-core polyplastic, the HDM plastic. And so when you carve off the surface, the inside color is different than the surface, and we can create these really neat signs with relief to them. And so the students started manufacturing and making these plans, and we discovered just how easy it was to do things like V-carve and stuff like that with Rhino Cam. And we're able to start making projects that the students could do. This last spring, excuse me, we had a prominent pilot in our community crashed his plane, and he and 3 other people died in the crash. And the family approached us, and we ended up making a headstone for his grave with out of very, very beautiful African mahogany, and my students designed and carved the headstone for him.
Wow, that's nice.
Yeah, in a similar fashion. And so there's a lot of things like that in our community that the community comes to us and has us do. So aside from a lot of pro bono projects in the community, if you go to the next slide, I'll show you what our Keystone project is. Our students, before I came here, the previous instructor had built a marine fabrications program, and the kids had been building boats for 20 years. And so our high school students each year build between 1 and 3 aluminum boats, and these are full-size 20-foot jet or ocean boats that they are paying for the materials and building on their own.
And you're using Rhino Cam to build these?
Well, we're getting there. So they used to build it manually, and so then when I got here and I started using the Rhino Cam and everything, we started seeing how we could start manufacturing the parts more precisely, because they were manually cutting them with skill saws on the aluminum. And so we started designing out some of our basic jet boat designs on Rhino, and then transporting them over to Rhino Cam to make our cut sheets and things like that. And in the picture on the right there, you can see our first set, well, excuse me, that's our second set. The first one we cut was a small 9-foot rowing pram for going to the beach from a larger boat. But here you can see all the parts cut for 2 14-foot jet boats. And this was designed out, and you can see on the left there, we cut a 1-to-1 scale model and had the kids put that together, glue it together and everything. And the layouts that you see there represent the half sheets of aluminum that we used on the machine to cut it. And once all those parts were cut, they actually put the boat together. And you can go to the next slide now. And here you can see the students assembling that jet boat. There's one there and one behind the students sitting next to it. And we were able to put that jet boat together with a precision that we weren't able to do in the past. And so designing them out and actually machine cutting them was an amazing step forward. And we're actually working now to make a program, a statewide program or a regional program, where we can start cutting parts for districts that don't necessarily have the technology or the facilities to cut and manufacture their parts from scratch, but have a welding facility where they may be able to assemble it. And so what they would do is come to our school and have a weld training program. We would use our Rhino program and our cutters to cut the parts, bend the parts that needed to be, palletize it, and send it to their district where they can then start to assemble it.
Yeah,
So,
I see this next slide here coming up. That's the boat complete. That looks...
Yep, let's go to the next slide there and you can see it.
Now, did you take this out on the water?
Actually, it's been running around since its completion. The student that finished it ended up blowing up one motor already and rebuilt it. But it runs off of a jet ski motor, about 120 horse jet ski motor. The boat itself is light enough that the students, 3 or 4 students, can pick it up. And but we have the Stikine River here, which actually runs up across the Canadian border and the students that built this and the one next to it use that boat frequently for moose hunting trips and just weekend cruises and stuff, and it runs beautifully. It came out very, very well.
Well, that's great, Drew. I appreciate the discussion in the presentation. Drew, I'm curious. I want to switch over to you with the same question. I'm curious about how the younger adults in your school have embraced the CAM technology and fabrication.
Well, to give you an example, the young lady that made the grave marker this last year, she went through the tool paths and everything, and it was a pretty basic V-carve and you know, the 2D outline and everything. But tell you what, when it actually came to running the machine, she was just about flat terrified, because the piece of wood that she was cutting was about a $200 piece of wood, and she was concerned that she had made a mistake, even though we had run the file about 4 times on cheap plywood. She was very concerned. But
yeah, I can understand that.
Yep, like Bill said, it's, you know, they can pick up the digital aspect of it, and they can see it run on the computer, and they believe the computer. But then, like he said, understanding how, you know, and I had to talk about densities of maybe a knot or whatever and stuff, understanding how that material will react is, like he said, an amazingly difficult thing for them to understand. But like Bill and I, you know, he and I have cut thousands of pieces of wood and plastic and different pieces, and we understand how that material will react to the machine.
Right. Uday and Joe, did we have any other questions from our attendees?
Not right now, but I have a comment to make. You know, one of the modules that we do have is the free mill product that runs completely inside of Rhino as well. And Don, you actually, when you showed the drop down, you kind of moved over that free mill.
Yeah, yeah.
Yeah, what I wanted to let our attendees know is, you know, that's a great way for your students to, you know, run CAM. Free of cost. It's a completely free product, so you can get that product. I actually download our product and run free mill. You can actually machine small parts. In fact, the Pittsco part that you had, Don, can be completely machined using free mill.
Yep.
And it includes all of the post processors, so you know your students can use it. They can build little parts with it.
And so actually, it's a good way for them to learn initially about the program and
exactly, yeah. So yeah, without even spending any money, you can actually take it and run the product. So I just want to bring that to our attendees' attention here.
Uday, I would add to your comment there. The free mill, I was struggling with the Bobcat cam one weekend, trying to help a paddle making class make a 3D paddle on our mill, and couldn't get it to work. I downloaded the free mill, plugged it in, and within 15 minutes I was able to cut the paddle, and that was the decision. Wow. That was the moment that made my decision to buy the actual the Rhino Cam, because the Rhino Cam offered the ability to pick and choose your tool paths a little more and decide how you wanted it to cut. Whereas the free mill
that's great.
Yeah. So that was the deciding thing. It gave me the opportunity to try your product and get a feel for how easy it was to use.